Good afternoon, students. So, in last lecture, we have completed the syllabus of 8085 and we'll be starting with 8051 from today's lecture. But the very first question is when I say 8085, uh, when I say 8085 or I say 8051, what's the difference between these two? So, very first difference is that this is a microprocessor. This is a microcontroller. So that directly brings us to the next question. What is a processor and what is a controller? Okay. So basically a processor, a microprocessor is a device which has ALU inside and which has some computing power, like it can perform some arithmetic and logical operations. Okay. Uh, in general life, it has a higher speed compared to your controllers. The speed would be higher. In general case, I'm not discussing about 8085 with 8051 right now. But in general, this execution speed are far better compared to the controllers. When I talk about processor, the one more advantage is you can have your own system as per your requirement. What does that mean? That means you can design your system like I can have a memory whichever I want. I can have the other peripherals. What are the other peripherals? So it can be a serial communication module, it can be a timer, it can be some interrupt handler, and there are a lot of modules available. Okay, some real-time data aggregation system. So RT is the name, real-time unit. So this kind of peripherals you can have with your processor. Okay, so you can design your own system. On the other hand, there are some disadvantages with the processor. Okay, very first is not ready to use system. What does mean not ready to use system? So when we learned 8085, at that time we have learned one thing, that if I buy 8085, it's a 40-pin IC which does not have a memory. So, and you cannot store program without a memory. So very first requirement of developing any system based on 8085 is you need a memory. Okay, so generally your processor does not contain a memory, but if I compare it with the controller are more robust device. So basically what does they have at center, they have again ALU will be there. Okay, or you can say it has a microprocessor itself inside, you can say it like that. Okay, and along with that it will have some memory, it will have some input output unit, it will have some other like this kind of peripheral devices. Okay, and everything that I have told you is on single chip. So if you go to the market and if you buy this 8051, you'll get lot of things on chip. Okay. On single chip you have memory, you have your processing power, so your ALU is inside there, your memory is there, your ports are there, so you can do your input output thing. That's the difference. That's why a processor is the totally different device and controller is the totally device. Generally, where we use a processor is general purpose computing system. General purpose computing system. What a general purpose computing system means? Your desktop, your laptop, your mobile phones. That even not even a mobile phone, but mainly your desktop and laptop, then supercomputers or some statical computers are there which can perform a data So this kind of device use microprocessor. So basically, what's the advantage over there? Like, why? What is the advantage when I use microprocessor inside my desktop? The first advantage is I can design my own system. So if I need 4 GB RAM, I can have my 4 GB RAM. If I need 1 TB of memory, I can have 1 TB of memory. If I need network card, I can install a network card. So you can design your own system. That's what I mean. The other thing is that when you have a microprocessor, you can do general tasks. General task means I can watch movie on my computer. That's one task. I can do gaming on my computer. That's different kind of task. Then I can do some software, like you can have MATLAB, you can have Python. So these are the general computing. Okay, general computing systems. You need a separate software or separate set of instruction to perform some specific task. So you can do this kind of work using your processor. But in case of controller does not have that much of power. So controller is like efficient device to work with, that are efficient device, but that are not like general purpose device. Okay, they are more built toward application, like keeping the application in mind. For an example, your microwave circuit, your washing machine circuit. Are you going to open the microwave circuit and going to reprogram it? You're going to do it like that thing. Are you going to run MATLAB on microwave? That's not the task that microwave should perform. So basically, a microwave, washing machine, your refrigerator, your TV remote control, your TV itself, they all devices generally use controller. So what's the advantage of controller over there? Like even you can use processor over there. Processor can do all that task. But why I'm using controller? Because it's a single chip and cost-effective device. It's a very small device. Memory is not separately required. Some peripherals are not required. Everything is on chip, so I can use that device directly, and it's cost-effective solution. Okay, and I know as a consumer, I am not going to uh, reprogram that things that given inside. Okay, so what do you do on microprocessor? Your microwave oven. What generally we do? Generally, we give some inputs like this should be the temperature, this should be the time, and we start, and then it do its work. So that program inside your microwave oven or your washing machine is a fixed kind of program. We are not going to modify it over time, and that's the specific task that has to be done. Okay, so in this kind of devices where you do not require any new extraordinary work, in that kind of environment we generally prefer to use microcontrollers. That's the basic difference between a controller and a processor. And now, as we have already covered a processor, like how a processor look like, now we'll go inside a controller, like how a controller works. And specifically we are going to discuss about the 8051 microcontroller. Okay. So 8051 is like set of families there, like it's not a single IC. Like 8051 is basically uh, one controller itself earlier, but as time goes on, it's an open source design. 8051 is open source design. So what other companies have done, other companies have taken that design and they have developed their own system. What does it mean? Just time being, I'm giving you an example. Let's suppose a standard 8051, a standard 8051 have 4 kilobyte of ROM and 128 byte of RAM. That's standard configuration. But if you go into market, you'll have some other version or other variant, okay, with some different like characters over here. You'll see 8051 somewhere inside the name, and in that module you might find 64 KB on chip ROM, and it is possible you can have 1 KB of RAM in that case. So that's own design. Okay, so what they have done, they have whenever they have open source this thing, open patented it basically. So at that time, the only requirement is if you want to copy this, if you want to produce your own 8051, the only thing is that it should work like the basic 8051 should work as it is, though you are creating your own version. Okay, so whatever program I write in this 8051 this variant, that same program would like should be running on this 8051 IC without any single alteration of single line code. That is the basic requirement. So the code should be same. Whatever you can do other than that, you can change peripherals, you can give some extra memory, you can give some extra peripherals, no issue in that. But the core concept of 8051 should be intact. That was the requirement. So there are n number of 8051 variants are available. If you just Google 8051, you will get n number of variants. Okay, let's do that. Let's see which are the makers of 8051. A lot of companies who produce 8051. Let's just see this Geeks for Geek website. See, even that these versions are available. Okay, these are like a different set of processor, different set of controller. Okay, but what I want to show you is yeah, overview of 8051 family. Yeah, see this one. Okay, so these are the different versions of 8051 and 8052. 51 and 52 are like brother sister. Some advanced features in present in 52, but we are only going to focus on 8051. Okay, so these are the part numbers. Okay, and what you get along with that is this. You can get extra memory, extra RAM, extra input output. No extra input output pin as of now. You can get extra timers. You can get extra interrupt and lot of things. Okay. Then there are other versions from the different manufacturer. Okay, who was the manufacturer? Dela Semiconductor. These are the version for the Atmel. Okay, 889C51, 889LV51, 889C1051. Okay, these are the part numbers. Okay? The IC number I can say, and these are the like features. This is the default feature. We are going to learn 889C51. So 4 KB of RAM, 128 byte RAM, 32-bit input output pins, 2 timers, 6 interrupts, 5-volt supply, and 40 pin package. But if you compare it with this one, let us say this one, 889C1051, it has only 1 KB of RAM, 64 byte of RAM, 15 input output pins, 1 timer, 3 interrupts, 3-volt package, and a 20 pin packaging. Okay, so this is the difference. Okay, but whichever program you write for this one should be running on this one. Then see this is also different now. Now the here speed is different. 889C51, 12PC, 16PC, 20PC. What is the difference? The execution speed is different in this case. Okay, so 12 megahertz is the speed, 16 megahertz, 20 megahertz. So this is this kind of difference are there. And now some advanced versions are also available. Let me just give an example. See, this is C8051 F12X. Okay, this is the name. 8051 is still there, but here, if you look into this specification of this IC, this is the course uh, of 8051. Yes, so, yes, thank you. So, so this C8051 F120 is actually in syllabus of your advanced microcontroller that you are going to learn in next semester. Okay, but before learning this, you must know basic 8051. So this is the advanced version of 8051. Okay, But if you look at this specification of this, see here you have ADC on board, DAC on board, then JTAP debugging, 100 pin IC is there. Then inside that the speed is 98 megahertz. You can run it on 98 megahertz speed. 8 kilobyte of RAM, 64 kilobyte of your ROM, then 8 byte port. 8 byte port, okay, but how many port? 8 byte wide port, but 8 ports are there. So basically there are 8 ports. What is the port? We are going to into that. You only have 4 port in 8051. That's the difference. Then there are 5 timers. Okay, so this is like way far advanced version compared to 8051. But this kind of versions are also available. But the one program that we are going to learn today, if you load that same program on C8051 F20 or F120 that you are going to learn in next semester, the program will work. The only thing that execution time will be different, otherwise program will work. So that's how different variants of 8051 is available. Okay. Now the book for this course, let me show you a book for this course. I have probably uploaded it. If not, I will upload it. Not here. Okay, it is not uploaded right now. Okay, I'll show you the book and then I'll upload 2-3 books over there. See this 8051 Mazidi. Yeah, Mazidi is the book. Mazidi is the name of author, and this dog almost clear. This is the book that you are going to use for 8051. Okay, and this is kind of not book. This is kind of PPT that I have already shown you earlier. But basically, whatever information I share will be available inside here somewhere. Okay, so now let us begin with your 8051 from first lecture itself. So very first is the features of 8051. It is introduced by Intel. Okay, Intel introduced 8051, referred as MCS51. So MC is a microcontroller system 51 in 1981. So that's the history. Okay, it's been like 40 years since this year, but after 40 years you are still studying this because it's a base of controlling system like any system. Okay, once you study this, whenever you see 8051 or 8085, it's called 8-bit architecture, okay? Because that are an 8-bit processors or controllers. But right now, which we are using is 16-bit or 32-bit or 64-bit architecture system, and they are far ahead in terms of computing power. But still we are studying this because 8-bit is very easy to understand. If I try to explain you 32-bit system or 16-bit system, you'll be bunking classes from tomorrow. That's the thing. That's why we still refer this 40 years old system as a study, and still people find it very difficult to study. Okay, so this is a 8-bit processor. Okay, again now I say controller and then here it is written processor. Why? Because inside that there is a processor, I told you. So a CPU can work only on 8 bits data at a time, same way 8085, same way 8051. Okay, that both are 8-bit processors or 8-bit controllers. So 8-bit controller is basically it can handle 8-bit data at a time. So you can perform 2 8-bit addition, 2 8-bit multiplication or division or subtraction, or any operation can be performed on 8-bit data only at a time. Then if you want to perform a 16-bit data, what you have to do? You have to do 2 8-bit parts after one each other. So let us discuss about the basic feature of 8051. Okay. So a very basic feature of 8051 is we know now first feature. What is first feature? It is 8-bit microcontroller, let us say. The second feature is it has 128 byte of RAM. Now before going into this RAM and ROM thing, you must know what is RAM and what is ROM and why we need that RAM and ROM and how it is different. And why we say મારા કમ્પ્યુટરમાં 2 GB ની RAM છે, મારું કમ્પ્યુટર તારા કરતા વધારે fast. Can anyone explain me that, like, what is the concept of RAM? General purpose computing matter that we use at our home. Can anyone explain, like, what advantage I'll get if I have more RAM? I expect some answer. Let us start with Aman. Roll number 23, Aman. Aman, please unmute yourself and answer the question. What's the importance of RAM in your computer? Aman, please unmute yourself. Even though you don't know answer, you just unmute yourself. Let me know whether you are attending the lecture or not. He might be not there. Let me remove him. And let me re-add him again, and then I will go to our question. Okay, Parth, go ahead. No, not Parth. Yes, yes. Roll number 31.
Yes, sir.
Yes, go ahead. Whatever you know.
પણ આપણે RAM નો મતલબ સર આપણે કોમ્પ્યુટર હોય સર એમાં જે 2 GB RAM હોય તો સર એ સ્લો ચાલે થોડું, અને સર આપણે 8 GB RAM કેવું કશું પ્રોસેસર હોય 8 યા 6 તો એવું કંઈક, તો સર એ થોડું આમ ફાસ્ટ બી ચાલી શકે.
Okay. Yes, Manish. Manish, you want to add something? Manish, I am not able to hear you. Don't know why. Dhairya.
સર રેમ એટલા માટે હોય કે મતલબ આપણે મોર ધેન વન ફંક્શન મતલબ બહુ બધા ફંક્શન એક સાથે ચલાવી શકીએ. દેટ ઇઝ કે જો વધારે રેમ હોય આપણી પાસે તો આપણે મતલબ 4 to 5 ફંક્શન કે 6 ફંક્શન એક સાથે ચલાવી શકીએ સ્મૂથલી.
Okay. Manish, try one more time if you want to add something. I'm not able to hear you. No issue. Yagnesh.
સર રેમ એટલે કે કોઈ આપણે કોમ્પ્યુટરમાં આપણે એક સાથે વધારે ટાસ્ક કરતા હોઈએ, જેમ કે એક સાથે 2-3 વસ્તુ આપણે કમાન્ડ આપ્યો કોમ્પ્યુટરને તો એ કેટલી સ્પીડમાં એને એક્સેપ્ટ કરીને એની પર વર્ક કરી શકે.
Okay. Kanchan.
रैम होती है रैंडम एक्सेस मेमोरी, वो रोम से ज्यादा जल्दी चीजें स्टोर करती है। तो अगर हमें कोई चीज परमानेंटली सेव नहीं करनी होती है तो वो रैम में सेव होती है, एंड
Correct.
इसलिए वो होता है।
Yeah, I want that answer. Kanchan was absolutely correct. Now let us understand what she meant. Basically, first I am talking about our general purpose computing system, and then I come back to this 8051. Generally, what do we have at our home is, let us say I have i5 processor. With this i5 processor, I have two different devices connected. One is known as RAM and the other one is known as ROM. More specifically, we don't say this as a ROM, we say this as HDD. Now, if anyone knows, this HDD is basically a magnetic device. It does have a motor inside, and there is a file kind of thing on which the data has been written. and this kind of device, this HDD kind of device, are very slow in nature. They are very slow and sluggish in the nature. Okay. So what happens is my i5 processor is very good at processing the data. Let us say, just this is just assumptive basis. Okay. Let us say it can execute 1 crore instruction per second. What does that mean? 1 crore instruction per second. So if you roughly take 1 data byte as a base, okay, 1 data byte. If it's a 8-bit processor, I can say 1 data byte as a base. So 1 crore instruction means 1 crore data bytes. Okay, so this is 1 crore. Now let's try to understand how much data it is. Okay, so if I divide this 1 crore data byte by 1000, I'll get in KB. Okay. If again I'll divide it by one more 1000, I'll get in MB. So at least it's a 10 MB of data per second, and it's quite faster than that. This is just on assumptive basis. Okay, so at least to process this at a full speed, I need continuously 10 megabytes of data per second. At least I need this data. Okay, this one is way faster, I know that, but this is just on assumptive basis. Okay, so what happens is this sluggish device cannot support this i5 processor in terms of providing a data. So if this device is slow now, okay, if this device is slow now, what will happen? It will make this also slower. That's the point. Okay. Have you ever heard about a relay race where there are like more than 4 points are there? One has to reach from here to here. If I reach from here to here, let us say 30 seconds. Okay, the other person will start running from here. He will reach here in one more 30 seconds. Okay, and the last one here take, let us say, 60 seconds. So overall time is reduced due to this one only. Same way here, if my ROM cannot provide the data at required rate, in that case, though even though my processor is like very fast, then also the the speed will be limited due to the data transfer rate. Okay, that's the issue, and to solve that issue you have this device known as RAM. So what basically how basically things work. Whenever you run any program, the important data of related to that program will be bringed from ROM to RAM. Okay, it will be bringed here. Now this device is very fast. Okay, basically these are the static device, and static devices are always fast in nature. This is a magnetic device, and it is like there is a moving device inside, and this one is a static device. So static devices are way faster than that. Okay, then what's the issue? Why cannot we use static ROM instead of HDD? Why cannot we do that? So you have heard about this SSD. Nowadays this is in market, SSD, and 40 GB of SSD cost same money that you require to buy 1 TB HDD. Okay, that means if you are gaining on the speed, you are also gaining on your cost. Okay, so cost is also increasing if you go for higher size of static devices. Okay, so this is SSD is very fast. Like if you have ever used the device with SSD, you'll see it will boot up in 1 second or 2 seconds. Okay, as soon as you press the power button, in 1 or 2 seconds you will see your fast desktop. That's the processing power of SSD. That's the data transfer is possible at very high rate. So due to this reason, what we have RAM. So here I am going to store my all the temporary data. What does mean a temporary data? The data which can be important to the program for a moment. Okay, so that data may be stored inside here. So what I'll do, I'll take the copy of data and I'll put it inside a RAM, and then this device is very fast, so it can process with the speed of my processor. That's the thing. That's why we need RAM. Okay? And generally we say that's a temporary data. And a more specific term for a RAM is volatile memory. We call it a volatile memory. What is a volatile memory? Volatile memory is the kind of memory which will be vanishing away after your work is done. For an example, I turn on my computer, I do some task. There would be some data inside this RAM. As soon as I switch off the computer, or I turn off the computer, the data will be vanished. Okay, so it will become some random data. Again, I'll turn on, again I'll process, again some data will come inside RAM, again it will be vanished. But at that time, ROM is very helpful. Though this is a slow device, but it is non-volatile. What is non-volatile? It can store its content up to some time. Okay, up to some time, like it depends on the device to device, but it can store the content for time being. Okay, or time being, or I can say longer amount of time. That would be the better one. So that's why we have both of this on a computer system. Same way here. Same way here. Here the reason is not that. Okay. Here the RAM and ROM reason is not that. Basically here in RAM we store the data. This is the old architecture. So speed was not an issue at that time. So here this 4 KB of my ROM. Okay. Though I written 4096, better I should write 4 kilobyte of ROM. That ROM as well as this RAM are on chip. What does that mean? On chip means if you bring in this 40 pin IC that we have seen yesterday, inside this chip itself you have RAM and your ROM. So what I'm going to do with my RAM and what I'm going to do with my ROM, we are going to see the internal structure of RAM later on. Okay, but here I am storing my temporary data. For an example, if I want to perform addition, then whatever are the number, that number will be stored inside my RAM. Okay, so we have studied that resistor A, B, C, D, E, H, L in your 8085. Same resistor are inside RAM. Okay, so RAM is kind of that resistor. If you want to process something, you need that data inside that resistor. Same way here, if you want to process some data in your 8051, you need that data inside your RAM. Okay, and ROM can be used to store your data and your program. Then later on, you can move your data from ROM to RAM to process. Once it is processed, you can move it back from here to here. That is possible. You can move your data between RAM and ROM, no issue in that. But ROM is on chip as well as RAM is on chip. But whenever you are performing arithmetic or logical kind of operation, at that time RAM will be more involved in your operations. Okay, and sorry, RAM is more involved in the operation, and ROM is the device where I'm going to store my data or program. So obviously it would be larger because my program can be larger, my data can be larger, but temporary data can be smaller. So that's why I have only 128 byte of RAM and I have 4 KB of ROM. That's about memory. The next feature is I have 2 timers on 8051. What does a timer mean? We'll not discuss it right now. We'll check it out later. But this is just a feature you just have to remember as of now. Other feature is 1 UART. What does a UART mean? This is related something related to serial communication. We'll see this in detail whenever time comes. We are not going into that right now. And there are 4 port. You may see 4 port, or the other way to write this is 8 into 4 is 32. 32 input output pins. You might see this or this. That's the same thing. You may see 32 input output pins, or you may see 4 ports. Okay, but the 4 port method is like a better way to say it. Now what does that mean? So suppose I have an LED like this. I have this LED with me, okay, which I can turn on and turn off, which I want to turn on and turn off. So with 8085 you cannot do this directly because it does not have any input output pin. Have you ever used Arduino? Has anyone used Arduino? At least જોયું તો હશે. Yeah, at least જોયું તો હશે. So Arduino has that GPIO pin. આપણે એવું કહીએ ને Arduino પાસે GPIO pin હોય. that GPIO pin is similar to this port pins. This is general purpose input output pin. Same way, this is 32 input output pins for user. I can program it according to myself. So here, if I have 8051, I can directly connect my LED to one of this 32 pin and directly I can turn it on and turn it off. But if I have 8085, what I have to do? With 8085, you have to create a separate port. Okay, so what is a port? That would be basically a latch LS343 or some latch would be there. A bidirectional latch would be there, and using that you are going to connect it with address bus, and that by using address bus you are going to create this as a port, and then I can connect my LED at this point. So to connect this LED, you require a lot of hardware in between. But if you have 8051, you can directly connect your LED on a single pin. No issue at all. Okay, we are going to do that in like next lecture. We are going to connect LED. I'm going to show you in the practical how I can connect LED. So that's the first thing. You have 4 ports, or you can have a 32 pin. Now, what is the relation between the 4 and 32? Basically, one port is 8-bit long. Okay, or has 8 pins, I can say. A single port has 8 pins, so 8 pins and such 4 ports. So 4 into 8 is 32. That's why I have written 32 input output pins. Okay, if it is still remaining, we will cover that. Okay, and there are 6 interrupt source. So we have 5 interrupt source in case of your 8085, but here we have 6 interrupts, and we are going to see each of this interrupt separately. Okay, so firstly we'll try to cover these things. And your first unit, I don't know the unit number, but first we'll try to cover this. Then there is a separate chapter for these things. A port will be covered here, and then after that, once you know everything, we'll learn applications. Okay, so let me open this syllabus just to give you a brief idea how we are going to work. Where is the thing? No files here. I haven't given you syllabus, I guess. In that case, I'll upload it. No issue. But I don't have syllabus now. That's the issue. Just a moment. Let me get syllabus. Yeah, this one is the old booklet. I'll send the new booklet where I have some updates. But basically, the structure remains same. This part remains same. So we have done this basics of 8085. Okay, almost we have completed everything inside here. This memory organization is the only topic that we have not covered. Okay, where is it? This external memory interfacing. That's the only topic that we have not covered. All the other tasks has been completed. Other than these things, we have also learned how to do assembly programming with 8085. So we are not going to cover assembly level programming in this controller. Okay, rather we will start this controller with C directly. So first we'll do comparison. We have done that. Introduction to 8051 family, we have done that. That's not so important. Architectural block diagram. This is the thing from which we'll start. Architectural block diagram. Pin diagram, pin functions, general purpose and specific registers, memory organization, crystal frequency, crystal connection, calculation of speed execution, 6 clock, 12 clock mode operation, and port structure. That's the first part. Once we complete that, then we'll start with software and hardware requirement of programming and programming language, like kind of here assembly and C is both written, but we will only cover C in this. Okay. Then we'll learn on-chip hardware or peripherals. So you'll learn interrupt, you will learn timer and serial. That three part will be covered here, and at the end we are going to do applications. Okay. So inside application, what we are going to do, we are going to use ADC, we are going to use DSE, we are going to use relay with 8051, we are going to use LCD with 8051. There are lot of applications over there. So these are the various devices which we are going to interface, and then at the end you can have this application. Okay. So we are going to do everything, but first, to reach at this point, you must know chapter number your 2, 3 and 4. Okay. That's the basic requirement. So let us start with the basic diagram of 8051. You will see two diagrams, but for 8051 this diagram will work, okay, in your case. So this is the architecture of your 8051. This is not actual architecture of 8051. Let me show you actual architecture of 8051. I will. I don't have it over here. See, this is the actual architecture. Okay. Again, I am net outside the same. Why is like every slide that I get is PPT. Examdailies.in, actionworld.com, quizlet.com. Okay, rather I do one thing: copy image, open image in new tab. That will work. Okay, see, this is the actual architecture, but we will not have this. Like, it would be very difficult for you to remember this. But let us time being learn this and then go back to the one. I need a good quality image. That's my requirement. This is the wrong image. This will work. Same issue over here. Okay, no issues. Here, let me take the one that I have. Just a minute, it will take 1 or 2 minutes to get me to the book. Charles 1617 material EE303.01. Open file location. See, this is the actual data sheet of 8051 and it's not available in here. This is the other book that we are going to use. Jivan Parab is the name of the author, but here also same issue. No. And this is the third book. This is the book written by Ayla, Kenneth G. Ayla. I have Yeah, okay, got it. See, this is the diagram. Now it would be visible clearly. This is the diagram. Like the orientation might differ, but this is the diagram. Okay, or this kind of architecture is there. So what does this shows is, first you have your ALU somewhere over here. Where is the ALU? ALU is not shown in this figure. That was the issue. That's why I was not opening this thing. Okay, let be it as it is. This is the ALU here. Okay, this is the ALU, and with ALU you have to temporary resistor, and then there is ACC. So this is my accumulator, and this accumulator is not known as resistor A. If I say there is resistor A inside your 8051, that's wrong. You have accumulator in your what I say 8051. There is a resistor B as also. Okay, so you can say this is a resistor A. Okay, because there is a B, and A and B is used as a resistor at some point of time. Okay. Other than that, what you have is memory address register, and there is a RAM. Okay, so basically this will handle the addresses of RAM, because 128 byte RAM is there. So whenever there is a memory, there is a structure of a memory. Then here you have a stack pointer. The stack pointer work same way as of 8045. Only difference is this would be an 8-bit stack pointer rather than 16-bit. So here your address would be only 8-bit long. Okay. Along with ALU, you can see here the PSW. That's a program status word. So basically this is a flag register of 8051, and it looks different than your flag register of 8085. Here you have different bits. Okay, we'll see that what are the bits. Then here on this side you have flash. Flash means your ROM. Okay, so this is my internal data bus. This black line going from all around there is my data bus. Okay, so a lot many devices can put the data on data bus. This is my port 0. This is my port 1, port 2, port 3. There are port latches. Why it is written as latches? We'll see that reason why it is written as latches. Okay, and then there is a port driver. Okay, there is a port driver with each port. Okay, and here your interrupt serial communication and timer unit is there, which is connected to port 3. Why it is connected to port 3, we'll see that, we'll learn that. And on upper side also you have your port drivers. On this side you have your program counter. Okay, the program address register is the name, but actually it is a program counter. Then there is a buffer. Okay, which buffer? This buffer is in between your data bus, and then on this side I have kind of address bus. Okay, not actually address bus. This is kind of address bus. Your actual address bus would be this, like from here to here. So port 2 and port 0 will work as your address bus. Okay, we'll come into that why it's like that. Then this is a PC incrementer, so it is basically program counter incrementer register, program counter. Okay, so this is all related to your addressing your flash memory or your external memory, whichever you want to use. And then there is a DPTR. DPTR is the data pointer that I am not going to get into. And here you have your timer control unit and instruction register. Okay, so wherever there is an opcode will come here. It will be getting like executed in here somewhere. And here I am going to connect my crystal. So very basic, but it will be difficult to remember. So we are not going to follow this. But in exam, if it is asked like draw the diagram, then you have to draw this diagram. So what does this diagram? So it shows the central CPU. This is my data bus. On chip ROM is connected with CPU. On chip RAM is connected there. Timer 0, serial port, input output port, bus control. Oscillator is connected with CPU. Interrupt control is connected with CPU. So this is the diagram. Okay, so input output port is port 0, port 1, port 2, port 3. Serial port is TXD, RXD. Okay, and timer 01 is this two counter input pins. Like where these things come from, we'll come back to here later on when we learn everything. Okay, so I'm going ahead. These are the variants of your 8051. Subset of 8051, you can say 8052 and 8031. 8031 has no memory. On chip memory 0 KB. You need external memory in this case. So these are all the variants. Now assembly level programming, we'll skip it. I'm not going into that, but the part that I need, okay, is this. So now from this point, we'll actually start your actual journey of 8051. Okay, so let's begin with 8051. Whatever I have told you this point of time is basically theoretical information. You can find it anywhere. There is no concept behind that. You can find that theory information anywhere on the internet, in books, you will get it. Okay, but this point onwards, what I am going to talk would be like not always available in some written material. Okay, this is basically concept that you should understand. So now we'll be starting with very first word of 8051, and whenever I discuss about 8051, at that time you will see or heard this word SFR. What is SFR? That's the first question. SFR is basically a special function register. Okay. So it's again kind of register, but the function is very special. For an example, you have a register A, B, C. Same way, this SFR is kind of this register, but it has a special functions to it. What kind of special function? That's the next question. Okay, so there are a lot of special function register. Sorry, not king. What kind of special function? There are a lot of special functions available in this register. Like there are a lot of SFRs available. Okay, let me list out some of them. The very first SFR that we are going to use is named as P0, P1, P2, and P3. By name, you must guess this. This is related to port. Okay. So basically, these are the port numbers. Okay, so there are 4 ports, I say. So that 4 ports are named as port 0, port 1, port 2, and port 3. But whenever you want to communicate with your port is basically input output device. Okay, so input output pin. So how does a port look like? First question is this. So let us say this is my 8051, and on your 8051 you have your pins like this. Let us say this is P1.0, P1.1, P1.2, so on so forth up to P1.7. This way you will have your 8 pins. So this is my port 1. This combinedly 8 pins. Okay, 0 to 7 is actually 8 pins. P1.0, P1.1, P1.2 up to P1.7 are actually 8 pins, and that 8 pin combinedly form port 1. Now if I want to send some output, okay, I want to send some output. In that case, I can use this port. So how to send that output? So to send output to port 1, what you have to do? You have to transfer data in P1 register. So if I put my data, okay, let us say my data is 05. I want 05H as a number to be outputted on this 8 pins. So what? How should it look like? It should look like this. It should be 1 0 1 0 0 0 0 0. This should be the output. I need this output. So in that case, what I can do? I should move this number in this port 1 register. Now port 1 register is a special function register. So as soon as you write something in port 1, register, immediately whatever you have written on the port register will be available on the port pins. These are my port pins. Okay, so this is my port pin, this is my port register, and that two are different. Okay, so if I put something inside port register, immediately whatever I have written inside a port register will be available on the pins as output. Okay, now 05 was the data. Okay, but actually 05 is this. Actually 05 is this. So same way, this is a 8-bit data. So that 8-bit data would be available on 8 pins of port 1 like this. As simple as this. So this is a special function. So whenever you want to output anything on port 1, what you would be doing? you would be writing that data inside your port 1 register, that is P1. So P1 is a special function register. Okay, it will not do any other task. Whenever you will get it some data, let us say one more example. If I write P1 is equal to, okay, see I'm writing now, I am teaching you C along with this. Okay, so if I write P1 is equal to 0x A5. So A5 is the data. I am writing A5 in P1 register. Whenever I write this, P1 is equal to 0x A5, and that means this 0x is written to represent a hex number. A5 is the data itself. And when I write P1 equal to, so P1 is on the left side at that time, that means this data will be stored inside a P1, or I can say A5 will be written inside a P1. And P1 will become A5. As soon as it happens, immediately your port pin will change the status and your port pin will become A5. Okay, what is A5? A5 is 0, 1, 0, 1, 0, 1, 0, 1. This is A5. So immediately this data will appear over here like this. 1, 0, 1, 0, 0, 1, 0, 1. Okay, so this is the way your special function register works. This is just a single example of special function register, and there are such 4 registers. So if I write, let us say if I write P0 is equal to 0x59, what will happen? Your port 0 pins. Okay, this is port 1 pin. Same way I will have port 0 pins. It would be starting from P0.0 up to P0.7. And this data will become 59. Okay, how to write 59? You know that. This will be the data, not should be. This will be the data. So if you write anything inside a port register, okay, these are the ports. There are 4 port registers dedicated to each port. So port 0 register is P0, port 1 register is P1, port 2 register is P2, and port 3 register is P3. So if you write any data inside any of this register, immediately you will get that data on pins. What do I mean by pin is actually this pin. When I say, sorry, not maps, yeah. When I say pins, I mean actually this pins. I literally mean this pin. Okay, if you do that, literally 59 will be available. So if you connect LED to each individual pin, whichever are the ones will turn on and the other will be turned off. Okay, that literally means that the data will be available on that pins. Okay, what I have done, I have written inside a program, I have written P0 is equal to 0x89, and due to that this status of this pin has been changed, like 101010 something, and that has been appeared on over here. Okay, so that's the actual meaning of that. So that's why we say this is a special function register. Whenever I write something inside that register, a special function will be executed. What is the special function here? The special function here is to have output. Okay, so we'll stop here for the today's lecture. If you have any question, you can ask or you can leave. Yagnesh, you want to tell us something?